Hey everyone, welcome. Today is all about leveling up your code. We're going to look at 4 super powerful but honestly often misunderstood tools that'll make you a way more precise and effective developer. Ready? Let's jump right in.
All right, let me ask you something. When you're up against a common coding problem, like comparing two files or digging out the max value from a dataset, are you really confident you're using the best tool for the job? Or is there a little voice in your head wondering if there is a smarter, maybe more elegant, or even just a safer way to do it?
Well, over the next few minutes, we are going to do exactly that. We're going to break down 4 of these common problems and add 4 seriously powerful interview-ready tools to your personal toolkit. Think of this as a quick-hit session to make you a sharper, more confident developer.
Okay, tool number 1. Let's start with something we all do, probably more than we'd like to admit: comparing files in a Unix environment. The question is, are you grabbing the right command for the job? Let's dig in.
So here's the deal. There is no one-size-fits-all best tool. It all comes down to what you're trying to accomplish. If you need to see the differences in a text file, something you can actually read, diff is your best friend. But if you just need to know if 2 binary files are identical, byte for byte, that's a job for CMP. Now, if you're working with sorted lists and you want to see what's common or unique between them, like a set operation, COM is built for exactly that. And finally, for just a quick, are these 2 things the same? Integrity check, you can't beat a good old hash.
And you know what's cool? Even with just one command, like diff, you can totally change the output to fit your needs. That unified format on the left with the little plus and minus signs, that's the gold standard for code reviews and creating patches. But sometimes you just need to see things side by side, right? That view on the right is amazing for visually pinpointing the exact spot where things start to go off the rails.
So the big takeaway here is super simple. Match the tool to the task. If it's readable text, use diff. If it's a binary check, grab CMP or a hash. And if you're doing set operations on sorted lists, COM is your go-to. That's it. Simple, precise, and way more effective.
All right, moving on to tool number 2. And this one tackles a classic SQL interview question that, I swear, trips up so many smart developers. It's the max salary challenge.
So here's the problem statement. You need to find all employees who have the maximum salary in each department. And I want you to focus on that word, all. The real trick, the thing that makes this a challenge, is handling ties. What happens when 2 people are tied for that top spot?
Okay, so the first instinct for a lot of people is to reach for a group by. You group by the department, select the max salary, and it feels right, doesn't it? The query even runs. It doesn't throw an error. But trust me, it is fundamentally, silently wrong. Let me show you why.
Here's the trap. Group by's entire job is to squish rows together. It takes all the rows for a department and collapses them into one single summary line. And in that process, it has to pick one employee name to display next to that max salary. It just picks one, pretty much at random, and silently throws away anyone else who might have been tied for first place. Poof, your ties are gone.
So what's the right way to do it? Well, you've got 2 fantastic pro-level options. The modern, and I think more elegant way, is with a window function. It's awesome because it calculates the max salary without squishing the rows. But if you need something that works on older systems, the classic solution is a subquery join. You find the max salaries in one query, then join that back to your employee table. Both of them get you the right answer every time.
So if you take one thing away for your next interview, let it be this: group by with max of salary will lose ties. You need to use a window function or a subquery join to get it right. That's how you correctly return all the employees at the top.
Okay, on to tool number 3, and this one is it's so elegant. It actually builds on what we just learned, and it can make your queries so much cleaner and safer. We're talking about the power of tuple comparisons. So what in the world is a tuple comparison? It's actually pretty simple when you see it. Step 1, your subquery creates a list of pairs. So instead of just a list of salaries, it's a list of department ID, max salary pairs. Then, step 2, your outer query looks at each employee and creates its own pair, department ID, salary. And for the final step, it just checks, does this employee's pair exist in the list of winning pairs from my subquery? It's matching the entire package deal, not just the individual pieces.
Now this is the most important part. This is not the same as doing two separate checks, like where department in blah 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 and salary in blah blah blah. That is a recipe for disaster. Why? Because you could accidentally match the top salary from sales with an employee who happens to be in engineering. It's like mixing and matching. Tuple comparison is smarter. It makes sure the department and salary match for the same row. So the key here is positional matching. When you say AB in this, you're saying make sure A matches the first column and B matches the second column together. It's a fantastic tool for making sure your logic is rock solid.
And now for our fourth and final tool. This one is all about transforming data, specifically pivoting from a long format to a wide format, and, most importantly, doing it the right way so you don't mess up your data.
So when it comes to pivoting in SQL, you'll see these two patterns everywhere. On the left, sum with an if. On the right, max with a case. They look almost identical, right? And half the time, they'll give you the exact same result, which makes them feel interchangeable. But they're not. Their core behavior is totally different. One adds things up, and the other picks the biggest.
So when does this actually matter? It matters the second your data isn't perfectly clean. Just look at this table. See how ID1 has two different rows for January? This is the exact kind of scenario where one of these methods is about to give you the wrong answer.
And this chart just lays it all out. Look at that max case bar. It saw the 5,000 and the 1,000 for January, and what did it do? It just picked the bigger one, 5,000. It literally just threw away $1,000 of revenue. Now look at the sum if bar. It did the right thing. It added them together to get the actual total of 6,000. So here's the one simple rule you need to remember. These two patterns will give you the same answer only if you can absolutely guarantee that every ID month pair is unique. The moment you have a duplicate, max is not just wrong, it's dangerous, because it's silently dropping data. And that leads us to our final takeaway. Look, max case is fine if you know your data is clean and unique, but 9 times out of 10, sum if is just the safer, smarter choice. It's designed to handle duplicates by correctly adding everything up. It's just more robust. So there you have it, 4 really powerful upgrades for your technical toolkit. We've covered picking the right Unix tool for the job, whether that's diff, CMP, or COM. We've nailed how to solve for ties in SQL using window functions. We've seen the elegance of tuple comparisons for matching multiple columns. And finally, we know how to pivot our data safely using sum if. Okay, you've got the tools, you understand the why behind them, so the only real question left is, which problem are you going to go solve first? Thanks so much for joining me.